Hi everybody, today we're going to look at this Coke machine here that I masterfully drew, and we're going to talk about this idea about a relation, a function, and a one-to-one function. So it's a Venn diagram, so everything in here is a function, or is a relation. Everything inside this circle is a function, and then some of these functions are also called one-to-one functions. So let's talk about, let's review what those are. So let's say this over here, this Coke machine right now was a relation. Let's just say it's an R, acting as a relation. All a relation means, if this machine is working as a relation, it just means that if you give it an input, it gives you an output. So for instance, pressing the 1 button is the input. The button press is the input. Press 1, here comes a Coke. Great. Press the 1 again, Coke comes out. Press the 1 again, Sprite comes out. Press the 1 again, Coke comes out. Press the 1 again, Sprite comes out. I don't like Sprite, I want Coke in this case. So in this case, this is a relation. Is the machine a relation? Is there an input with an output pairing? Yes, there is. Every time I put an input, every time I hit a button and something came out, it's working, okay? It's fine. Okay, press a 3 and a Sprite comes out. Press a 3, a Mellow Yellow comes out. Press a 3, a Coke comes out. Now, this thing's jumbled up inside. It's malfunctioning. It's a relation. There's an input and output, okay? But it's malfunctioning. So if I want this thing to function, think about what the function means. Now, if I hit the input button, hit the 1, a Coke comes out. Now I got it taken care of. If I hit the 1 again, what better come out? If it's functioning, what better come out? A Coke, same output. If I hit the 1 again, same output comes out. I got that 1 again. I press the 2, a Coke comes out again. Great. Okay, now I know that every time I press the 2, I'm going to get a Coke out. Okay, press the 3, get a Mellow Yellow out. Great. Mellow Yellow, every time I push that 3, it's functioning correctly. So in a function, if you use an input, you know what the output, it's going to be a consistent output. It's never going to surprise you. If I use a 1, boom, spits out a Coke. Hit it again, I know I'm going to get a Coke every time. That's in a function. You can trust the function. You can trust the output. You can predict the output once you hit once you put the input in. All right. In that relation situation, now a function is a relation, but it's a special type of relation. It's a predictable relation, a relation where you can predict the output by knowing the input. That's a function. Okay, so it's functioning. This is a good functioning thing. Now, some of these functions, now I did something a second ago, and maybe you were a little confused about it, but I said, I pressed the 1, I got a Coke out. Press the 1, got a Coke out. Now, I've seen a lot of Coke machines around, and I've said, I pressed the 1, got a Coke out. This is a Coke button. So is this one. This one's a Coke button too. So if those are both Coke buttons, it's a function. Coke, Coke. Great. It's working. Hit it again, hit the 2 again, Coke comes out. Great. But here's the deal. If I see somebody, okay, and they look kind of sick, and they're kind of got, you know, maybe they got a womp eye, and they're coughing in their hand, and they kind of got stuff oozing out of their nose, and maybe leprosy on their skin. And I'm like, I do not want to press the same button that they just pushed, but I really want a Coke. I really want a Coke. And I know they're standing there with a Coke. I see they're standing there with a Coke. But I can't tell which one they pushed. I'm probably going to have to go without a Coke that day because I can't tell. I can't trust the input. So by looking at the output, I can't tell what input went in. I don't know if they pressed 1 or 2 in most Coke machines. So most Coke machines are called functions. If the Coke machine doesn't have that quality, let's say that this is labeled Coke, this is labeled Sprite, this is labeled Mellow Yellow. Now, if I come up to a person and they got a Coke in their hand, do I know which button they pushed? For sure. I only push 1. So in that situation, if I can figure out the input by just looking at the output, that's called a one-to-one function. 1, 2, I'll write it in red. So it's a different color of my Coke machine. It might be illegal to draw Coke. In a one-to-one function, I'm going to press the 1. I'm going to get a Coke out. I'm going to press the 1, I'm going to get a Coke out. I'm going to press the 1. Every time I press the 1, I get a Coke out. When I press the 2, I'm going to get a Sprite out. When I press the 2, I'm going to get a Sprite out. Every time I press the 2, I'm going to get a Sprite out. When I press the 3, get a mellow yellow. Press the 3, get a mellow yellow. See a guy standing there with a Coke in his hand, I know he pressed the 1. That's the one-to-one function. And that's why one-to-ones are special, is because I can now look at an output and go back and tell what the input was. There weren't a couple there aren't multiple choices. So let's look at some functions here. Let's look at some real math stuff. Okay, I'm going to give you an example of a function. There are two functions. One's one-to-one and one's not. Okay, so I'm going to look at f of x. F of x equals 3x plus 5. And I'm going to look at, and actually that is one-to-one function. That's a one-to-one function, right? And then I'm going to look at q of x equals x squared plus 2. No, x squared. We'll just do x squared. Be easier. Okay. You can't see that real well. Let me slide it down. You got to glare. Q of x equals x squared. Good. Okay, so let's test, first of all. We know both of these are functions because there's not a situation where, like if I put in a 1 here, if I press the 1 button, I'm going to get out an 8. If I put in a 1 there, am I ever going to get anything other than 8? No, because I'm always going to multiply by 3 and add 5. So we definitely know that they're both functions. If I put in a 3 here, I'm going to get out a 9. If I put in a 3 again, I'm going to get out a 9. Is there any number that I'm going to put in twice and get 2 different answers out? No, that's not it. So if I put in an input, so this is a function. Now we put lots of, we don't deal with relations very often, that things aren't functions. We study functions most of the time. The whole uncertainty thing, that's probability and that's statistics. And in this pre-calculus version, things are pretty solid. All right, so, but now let's talk about, could I go another step and call one of these a one-to-one function? Can I call one a one-to-one function or not? Well, let's see. This guy, let's say I have an output. Let's say I have f of x, the output. I don't know the input, but I can see the output was 15. I can see the output, 15, no, I don't like 15. 35. Okay, the output was 35. Okay, so now I'm going to solve for that input. Okay, I'm going to solve for that input. So I'm going to say, okay, well, 35 was the output. I wonder what the input was. So this is solving for an input. And I'm going to subtract, I'm going to divide, and I'm going to end up with, this is going to be equal to 30 over 3, which is 10. I think I know. I know that if I got an output of 35, I could solve. I got 10 out. Could it have been anything else? Well, no. I think I'm always going to have to solve this. I got to subtract this. I'm going to divide by that. So this is a one-to-one function. That's a one-to-one function. Over here, however, a quadratic function like this, let's say that I know q of x, the output spit out a 16. And this is the issue, right? Some of you are saying, well, yeah, now we know 4. But -4 also spits it out. So at this phase here, we know that q of 4 is equal to 16, but also q of -4 is equal to 16. So if I just see somebody was standing there with the output of 16, do I know what input they put in? No, they either put in a 4 or a 4. We can't single in on one input. So this is just a function. It's not one-to-one. Because there are a couple different outputs or a couple different inputs that could have given us that output. Okay. Let's look at it in terms of a table. Let's say I have f of x, and x, q of x. I won't say q of x. I'll say r of x, I guess. And I'm going to say this is 1, 3, 2, 5, 1, 3, 5, 5. And over here, I'm going to say 2, 1, 3, 4, 3, 9. No, not 3, 9. 4, 7. Now we have to trust that they're giving us the full story here, but these are the functions. According to this evidence, are these functions or are they one-to-one functions? What are they? Let's see. So, oh, wait a minute, I got two inputs. I'll have some students tell me that if there's two inputs, then if the input's listed twice, then it's not even a function. But notice what happened. I pressed the 1 button, I got out a 3. I pressed the 2 button, got out a 5. I pressed the 1 button, got out a 3. Wait a minute, I pressed the 1 button one other time. What did I get out? Oh, I got out a 3. So at least I can predict what I'm going to get out. So this is okay. It's still a function. So I know this is at least a function in this situation. Press the 5, get out a 5. There's never a time that I didn't press that. Now, if I switch this, let's say I change that to a 7. I pressed the 1, got out a 3, pressed the 2, got out a 5, pressed the 1, got out a 7. Uh-oh. Now I pressed the 1 2 different times and I got out different answers. So now it's not a function. So let's go back to the 3. Now it's a function, so I can at least write function under it. Okay, now if I look at the list of outputs, I say, okay, well, let's see, output of 3. If I get a 3, let's see, do I know I got out a 1? Let's see, I've had an input of 1. So that, if I got that, yeah, that was a 1. If I find another output of 3, there's an output of 3. Did I get out a 1 again? Oh, yeah, I did. Okay, good. No other outputs of 3. Now let's say I get an output of 5. Okay, so let's look around. 5, oh, there's another 5. This 5 came from an input of 2. What's this 5 come from? Oh, it's an input of 5. So I can't trust it. I can't tell what input it came from. So this is a function, but it doesn't work for the one-to-one function piece. Doesn't work for the one-to-one function. So it's just a straight function. Fine. All right, so let's go down and look here. Okay, press the 2 button, got out a 1. Press the 3 button, got out a 4. Press the 4 button, got out a 7. Okay, I know that according to this, I press the 2 every time I'm going to get out 1. Press the 3 every time I'm going to get out 4. Press the 4, I'm always going to get out a 7. Okay, now let's check. So I know it's at least a function. Now let's talk about the one-to-oneness. Let's see, I get out a 1. No other chance, no other inputs give me a 1. Get out a 4. Okay, I got an input of 3, got to me a 4. Okay, that doesn't ever happen. All right, output of 7. Okay, output just a 4, no other outputs. So this is a one-to-one function, because if I tell you the output, you can go back and be confident in telling me what the input is in that situation. Sorry, I got a fly buzzing around here. All right, last piece is on a graph. Let's say I have a graph sitting here. Okay, I'm going to graph this right here. This guy right here, this is the graph of Q of X and X, and this is the graph of P of X, and that's X. Okay, so what we got to remember on graphs is that all of these things are just input-output pairs. A graph tells us an input and output. So if I look at this right now, I think if I look at my inputs, if I press this button, the output is going to be somewhere down here. If I press this button on the input, the output's up here. If I press this button on the input, the output's up here. If I press this button, the output's up there. So I'm kind of pressing the input buttons. It's taking me to the output. In this case, I don't think there's any buttons here. Okay, there's no buttons on the input that'll give me 2 different outputs. So this is definitely a function. Now I'm going to look at an output, and I'm going to look at my outputs here. I'm going to look at this output right here, and I'm going to check. Can I tell what input it came from? Well, this output came from pressing the 0 button, but this output also came up right here. Same level output. So right there, I pressed this button, got this output, pressed this button, got that output. So this is only a function. If I get an output of this level, actually there's even another spot over here. There are 3 buttons that I pushed to get the same output that got me that rised up kind of the same height. Okay, over here, however, let's just check. Press this button, got that output. Press this button, got that output. Press this button, got that output. Fine. All my inputs are good. Now if I take the output, let's see. This output right here, well, that only happened right there. This output of height only happens right there. That only came from there. Good. No other time was it on there. How about this output right here, right there? No other time. So right there, that's the only input. Okay. So this one definitely was a function because of the first button pushing on the first button pushing on the inputs, but then it's also a one-to-one function. This one's a one-to-one function in this case. Okay. Now there are a couple things here for functions. If you think about a function, this right here, if I think about a horizontal line, that horizontal line is really pressing the output button and making a line and seeing how many times, how many inputs had that output. So this is called the horizontal line test. And if you have a graph, or if you show me a graph, you can justify why something is a function by saying by using the horizontal line test. A horizontal line should only cross a function, or any horizontal line should only cross a function once. If it intersects more than once, it's not a function because you've pressed the output button and it's showing you a bunch of different inputs where you have the same output. This one over here passed the horizontal line test, but it's also one-to-one. Now, a one-to-one would be also passes the vertical line test. Every vertical line, oh, damn it, I just screwed that up. Oh, it's okay. Let's get rid of it. Uh-oh, did I hear Amy? Yeah.